Here's a multiple choice question where you're given that u is tangent to the level curve. And to picture that, you should think of some level curves. Let's say you have some function here, and at this point you have a tangential vector u. Now, what does the gradient have anything to do with the directional derivative? Well, there's this really important formula that you must know, which is that directional derivative of f is computed by taking the gradient and doing the dot product with the vector that you're trying to differentiate with, the direction vector. And you also need to know some facts about the gradient. Gradient always points to the increasing direction, and it's perpendicular to the level curve. So let's say these level curves come with their levels. So let's say this is level 1 and 3 and 5, or some number that's increasing. In that case, at any point, the gradient will be perpendicular to the level curve. And there are two directions, right? There are two perpendicular directions. It could be this one or that one. But because the graph is increasing this way, this will be our gradient of f. Okay, so over here, the gradient will be here. What about here? The gradient will be perpendicular to this level curve, and it will be directed this way. And this actually tells us what's going to happen. Because gradient of f is perpendicular to the level curve, and it also points to the fastest increasing direction. Since u is tangent to the level curve, putting these two together, you can determine that gradient of f and the vector in question would be perpendicular. But what do we know about perpendicular vectors? We know that perpendicular vectors have dot product 0. Okay? Perpendicular vectors have dot product 0. And therefore, we know that the directional derivative would be 0. Okay? And therefore, among these, number 2 would be the correct answer.